everyone. Welcome. Today we have Dr. Gabrielle Hedrick, and she's going to be presenting about her Mars Rover project. So I'm going to turn it over to her, and I hope you all enjoy.
Hi, everyone. Thank you for joining. So I hope I'll make it interesting. But when it comes to Mars, it's always interesting. So I'm not worried about that. All right. So I'll go a little beyond what exactly I've been working on because, well, I have actually been working on a lot of things throughout the year. So I started by driving Opportunity on Mars. It's a shortcut for what I actually did, but that's what my friends usually said about it. Is like, hey, are you driving the rover today? And close enough. And then when I came to West Virginia, I continued working on the rover. But this time with my colleagues, we prepared for the next one that's not yet on Mars, but is going to be at some point. So I'll start with telling you about the history of, why are we going to Mars, how we actually get to Mars, how we land on Mars, why we want to be there, and then I'll move on to more recent progress, and then I'll obviously uh, leave some room for questions. Oh, and everything that I'm going to show you today, I used a lot of resources from NASA because they have an amazing outreach department. They made a lot of videos that I think are amazing. And even if I wanted to make my own, I don't think I could do as good of a job as they did. So I'm going to use everything, the pictures, the videos that I'm going to show you. It's all NASA credit. It's not me. I'm just, a little tiny dot in the middle of a huge collaboration, huge project. So everything is from NASA. So the first thing is, yes, we went to Mars. We sent several rovers. So that's what you see here. It's a family picture of all the rovers that actually went to Mars. So you have this tiny little one here, this little guy, the first one that we sent. And it was basically to say, hey, can we actually drive on a different planet? I mean, if you think about it, on Earth, we drive a car where we behind the wheel, it's pretty easy. But how do you do this when you're not behind the wheel and you have to be, thousands of miles from the vehicle to drive it? So that was that first one. And we decided to demonstrate that we could do it. And then we had the twin rovers. Is there anyone here who has heard of the Twin Rovers, Spirit and Opportunity?
My dad's heard of it. He used to work at Liberty Science Center and they were talking about NASA a lot.
Okay. So Opportunity is they're both important, but Opportunity actually broke the record of the longest distance ever driven on a different planet. And that's including, when the astronaut went to the moon and they drove a rover on the moon, they drove pretty far, but Opportunity actually managed to break that record. So unfortunately, we lost the rover in a ginormous dust storm 2 years ago. That was really sad, but I think, it had a really good life. And then Curiosity has been on Mars since 2012, a little bigger than the Twin Rovers. And then I'm guessing you've all heard about Perseverance and Ingenuity. Can you tell me which one is Perseverance and which one is Ingenuity? I have two here.
I think is the big one Perseverance.
Yes, absolutely. So this is the Perseverance rover that looks exactly like Curiosity. So it's the same type of vehicle, but you have different options on it. So it's not quite the same. It looks the same, but it has different options. And then this little guy here is the first ever helicopter on Mars. And I'll come back to it at the end because it's a really big deal because we've managed to actually fly on a different planet. So what do we do when we have a rover? Um, So I like this comic because, it's true that a lot of people are like, oh, you're always on your phone, you're always taking pictures. Well, sometimes when you go to a whole different planet, that's all you have. Okay. And that's what the little rovers actually did. And it's not that it's always on its phone, but it's always taking pictures. And we absolutely need this to understand Mars and to figure out, what is Mars like, what it's made of, or what we we want to know more about the planet, and we can't go there physically yet. So we have to find ways to get information about the planet, about the landscape, about the type of rocks, about, anything you can find. And by taking pictures, it also does some, experiments on the planet, obviously, but pictures are the main thing that we need. And the first images of Mars, it was huge. It was the first time that you could actually see another planet with your eyes. So they all have cameras, and we still take pictures from different parts of the planet. And I honestly find it fascinating. I think Mars is a beautiful planet. So we also have, so we have vehicles on the surface, okay? But let's not forget that we also have satellites in orbit around Mars. So, on Earth, we have a lot of satellites. We have here, when you want to go somewhere, okay, and you get in the car with your parents, and if they don't know where they're going, they're probably going to use the GPS on their phone, okay? And that uses actually a lot of satellites. They don't look exactly like this one, but similar idea. And there are a lot of them around the Earth, and we also have something like that around Mars. Now, we don't have the GPS on Mars yet, but it's actually an idea that's been launched. Where, can you imagine if we go to Mars physically, and then we can actually get our navigation directly on our tablet or phone? That would be amazing. Well, we don't have that yet, but the rover the rovers actually use the satellites to communicate with us. So they're very important, and they can also get us some images from the planet that, the rovers are limited to what they have around you. So for instance, here, WVU is in Morgantown, okay? So if you want to walk around WVU, you're probably going to be limited to the campus. There's so much you can do, when you're just walking. But if you're flying above Morgantown, you can see a lot more. You can't see much in details, but you can see a lot more than, walking. And that's kind of the idea with the rover on the ground. It's kind of you walking around, and then, the satellites are more like the airplanes flying over to get a bigger picture of what you're looking at. And all of this is important because when we want to plan the next mission, we need to get as much information as possible about the planet before we actually go there, because you can't just go there blind. You need to know as much as possible before you even launch a different mission. So
Nova, you
how
have
do
your
you
hand raised. Do you want to ask a question?
It's not really a question, but aren't TVs also on satellites? If I'm correct, I'm pretty sure they use satellites also.
Yes, I should have thought of that. I'm I usually say I'm a down to Mars person because sometimes I don't think about really obvious thing that we have on Earth. But yes, satellites, it's everywhere. It's everywhere on Earth. And we don't have as many on Mars. We have about 5. But, hey, why not actually get TV to the astronauts that are going to go there one day?
There's also a question in the chat that says, how long does it take to get there?
Well, I believe we'll get to this here. So how do you get to Mars? So this video, it lasts 1 minute, but it has a lot of good information on how to get to Mars. So average to get there, it takes 7 to 9 months. It really depends. It could take, 7.5, 8.5, but it's usually between 7 and 9 months.
Clarissa also has her hand raised. Do you have a question too?
What is inside Mars?
Sorry, can you repeat your question?
What is inside Mars?
Inside, so inside Mars is very similar to what we have on Earth. So you know, Earth is you have a core that's made of metal like iron and nickel, and then we have the mantle where we have a lot of like the lava from volcanoes will come from that deep in the earth. And then we have the crust, and that's what we're on right now. We're on the crust. Okay, so Mars doesn't have different, like the crust of Mars is not broken down like Earth. But it has a crust, it has a mantle. So we are not exactly sure the composition exactly of that mantle, because we don't have access to it. We're working on it. And then there's a core, and we believe that unlike Earth, the core is entirely solid, whereas on Earth, the core is still liquid.
We also have another question in the chat. It's asking about what it would take to live on Mars in the future, but I think you might cover that later.
I will probably cover it later, just in case I don't get to it. So to live on Mars, first of all, the atmosphere is really thin. It's not like on Earth where you go out and you breathe, you have a lot of oxygen, which is what you need. The atmosphere on Mars is very toxic. It has a lot of carbon dioxide that we can't process. So it would take, first of all, finding a way to adapt to the environment. So a habitat somewhere. So we would have to be inside something where we can have the right atmospheric composition so we can breathe. It would take, there's something on Earth where we're protected from the sun, which it actually has deadly radiation. So if you're exposed to the sun, and that's why you actually have to wear sunscreen in the summer, it protects your skin, but there are also radiation that you kind of want to be protected from. And on Mars, you won't have that because there's not enough protection there. So we would need to figure out a way to repel those radiations so we can live long term on Mars. I think I have other questions. I see the chat flashing.
Hey ladies, I think we'll answer some of these questions later in the presentation, so maybe wait till she finishes and we can discuss all of these later, okay?
All right, I'll keep going, and then we'll come back to questions. If I don't answer them during the presentation, I'll definitely come back to it. So how do we get to Mars?
How do you get to Mars? If you want to send a spacecraft all the way to Mars, first you'll need a fast rocket to escape the pull of Earth's gravity. The heavier your spacecraft, the more powerful your rocket needs to be to lift off. Next, make sure you launch at the right time. Mars and Earth orbit the sun at different speeds and distances. Sometimes they're really far apart, and other times they come closer together. About every 2 years, the two planets are in perfect positions to get to Mars with the least amount of rocket fuel. That's important. The total trip is over 300 million miles. Finally, make sure your aim is right. You can't shoot for where Mars is at launch time. You have to aim for where it will be when you get there. It's a lot like how a quarterback passes a football. Also, you may need a few thrusts to correct your direction along the way so you don't miss Mars. If all goes well, you'll get to the red planet in about 7 or 8 months. Then, if you actually want to land on Mars, well, that's a whole other challenge.
All right, so that's how we get to Mars. So there are a lot of things that we need to consider to even take off from this planet. Okay, so now say you actually manage to leave the planet. So you have the right rocket, you have the right timing, and you aimed correctly. Okay, and you corrected the trajectory along the way. Now, how do you land on Mars? Because that's a whole different story. Now you're there. What do you do if you want to get to the surface? And it's going to be true for astronauts as well. It's not only for rovers. You know, we want to send humans to Mars, and it's the same thing that applies to them.
How do you land on Mars? Very carefully. Your spacecraft hurtles toward the planet at thousands of miles per hour, so you'll have to hit the brakes in a hurry. First, your capsule needs a heat shield. It protects the spacecraft inside from the heat and friction of entry into the atmosphere. Friction slows you down over 90%, but not enough to land safely. Use a parachute to slow down even more. Still, falling at over 100 miles per hour, you need the right system to land safely. Here are some options. With a small to mid-size rover, use a cushion of airbags along with retro rockets. Impact at 30 miles an hour and bounce to a stop. With a large lander, use retro rockets and landing legs to touch down, going about 6 miles an hour. Or with a large heavy rover, use a big jetpack to slow down to under 2 miles an hour. Then gently lower it on cables to land on its wheels. Any way you do it, you'll need skill and hard work. There's nothing easy about landing on Mars.
All right, so we landed on Mars and we actually used all three techniques. So the small rover, the twin rover, Spirit, and Opportunity used the airbags, but Curiosity and Perseverance used option 3 because they were really big. So they needed way more than the airbags to actually slow down and land safely on Mars. And it is, if you're older, you've heard of it, but if you've heard of the 7 minutes of terror, that's the landing of Curiosity and Perseverance, because Curiosity was actually the first time that they tried the version with the jetpack, and they really didn't know. It was hit or miss, and it would have been a big miss. So fortunately, I mean, I really trust NASA at this point. They really know what they're doing, and they landed perfectly. So they reused that techniques for Perseverance, but it wasn't a given, which is why if you want to watch the video of the landing for Curiosity, or even another video explaining in more details what was going on, you need to search for 7 minutes of terror, and that should, and probably Mars too, but that should show up, and you can see in more details how it works, and how they invented that jetpack to slow the rover down a lot more. So now you're on Mars. You got to Mars, you landed safely on Mars, and we just did it again recently with the Perseverance rover. Do you know you actually drive on Mars? You guys heard about how we communicate with Mars, or how we do things with Mars? Anyone has an idea?
Summerly, I see your hand up. You can go ahead and shout it out.
I don't have a question. I don't have.
Somebody typed in the chat that they are thinking hard. Does anybody have an answer?
Whaley, do you want to answer? I see your hand up.
Go ahead.
Go for it, sweetie.
Whatever you want to say.
Thank you.
She asked how they drive them, how they communicate.
With computers.
Yeah, so that's true. So we're going to use computers on Earth, because remember, we're still on Earth. We're not on Mars. So you know how you drive your car. You get behind the wheel and you start driving. But we can't do that on Mars. So how do you actually drive on Mars? And I'm going to show you another video.
How do rovers drive on Mars? First of all, there's
Satellites?
no joystick for driving a Mars rover.
Yeah, satellite.
Before a rover hits the road, engineers send computer commands
Computer.
overnight, telling it where to go the
You
next
said
day.
that?
Depending on how tricky the terrain is, rover drivers have two options. They can send a string of specific commands like drive forward 5 meters, then turn right 90 degrees. The rover turns its wheels enough times to add up to 5 meters, and then turns in place. Or if it looks safe, they can let the rover think on its own. They write commands like, see that rock over there? Find your way there safely. Then, using 2 cameras like human eyes, the rover gets a 3D view of hazards such as large rocks and steep slopes. After mapping the danger zones, it plots the safest route to avoid them. Either way, did the rover complete its drive as planned? Engineers double check when the rover sends back a postcard of its new spot on Mars.
So as someone said, computers, that's the main tool that we use on Earth to drive the rover. And then we actually relay the information through the satellites. We very rarely communicate with the rover directly, because we can't talk much to the rover directly. You won't be able to say much. You might be able to say hi, but that's pretty much it. Whereas if you actually relay the information through satellites, you can say, hey, can you drive to that rock over there and, find your way over there without us telling you exactly what to do? Or what they can do, you saw that there were two techniques. They can actually do a combination of both, saying, well, the first few feet, we're going to tell you exactly what to do. And then from there, just drive to that nearest rock over there, however you think is best. So that's how you drive on Mars. And it does use computers a lot. So when I was on the opportunities team, and that's where my friend said that I was driving the rover, it's not one person that does it. It's a teamwork. So it was about maybe 10 of us. And we would do this. It took an entire day. If we didn't have any problem, we would be done in about 8 hours. But if we had problems, I remember, my Friday nights, and it was 11 p.m. and I was still in the office trying to figure out how to drive the rover for the next day. And when I say that, it means that we were still writing the code and we still had to send it, and it still had to get to the rover. So it was a very long process. As I said, sometimes, we would start at 8 in the morning, and at 11 at night, I would still be in the office, working on driving for just the next day. And sometimes everything would go smooth, and, by 5 p.m. I would be done. So it's a long process. It's definitely a teamwork. A lot of people throughout the US and even from Europe would call in to drive the rover. It was a very interesting process too, but we had several meetings to make sure, hey, we're going to do this. Everyone agrees. And then once we agreed on a combination of events, we would try and put it together. And then sometimes we would realize that we didn't have enough time to do as much as we wanted. We didn't have enough energy. It's kind of like a human being. At the end of the day, if you say you've run all day, played all day, you worked, you did your homework, at the end of the day, you're probably tired and you need to sleep because you need to recharge. That's the same thing with the rover. It needed to sleep to recharge before it could actually drive the next day. And sometimes it wouldn't sleep enough or it wouldn't recharge enough, and we couldn't actually do as much as we thought we could. So we had to chant, we had to drop some, hey, we wanted to take that picture, but we won't be able to because we don't have enough energy to do it. It's a lot of different things that we need to think about when we drive the rover. Different, do we have enough time? Do we have enough energy? Do we have everything we need? What are the obstacles? What are the things that we weren't prepared for and suddenly it appears? So it's a lot of work. It's not as simple as it looks like. And again, it's all from really far away. So I'm going to show you a couple of pictures from each of the rovers. So do you know which one this is? It might be a difficult question because the rovers look like each other. So take a guess.
Go ahead, Whaley. I see your hands up.
Wally. Yeah, that's you.
Wally, go ahead.
Perseverance.
Yes, we have a winner. This is Perseverance on Mars since, this year, a very recent landing. So, I mean, I don't know what you think, but I think Mars is beautiful. There is very little vegetation. Actually, there's not at all, but it's a different style. What about this one? A little more difficult because you can't see the rover. Anyone?
Laura, you have your hand up. Do you want to answer?
The helicopter?
This is not the helicopter. That was a good guess, though. This is actually Curiosity. This is what we call Mount Sharp. It's characterized by layers, if you can see those layers here. So very layered, and usually if you see something that is very layered like this, where you can see those strata here, it's probably from Curiosity, because that's the a characteristic of Mount Sharp, where Curiosity is.
My brother keeps on putting my baby brother's head in my video. No!
Okay, Kia.
All right, what about this one? And can someone tell me what this is? So which one of the rover took these pictures? And can you tell me what this is? I know it's difficult questions, but just go for it.
I see Catherine. You guys have your hands up.
Yes, I know what that is.
What is it?
That is a cliff.
That is a cliff. Absolutely. So do you know who took the picture?
I can tell the cliff's probably about 40 feet tall.
I think that's very difficult to say because we don't really have a scale to tell. And I have to say, I don't remember how tall it is. I should have checked. I'm sorry.
I see Tracy and Nova. Tracy, do you want to go first? And then Nova, you can answer.
Did the helicopter take that picture?
It's not the helicopter. This is only rovers. So Ingenuity is out of the picture.
Okay, Nova, you can try.
Okay, so sorry if it's super loud. I'm at cheer practice right now, but so I'm guessing it's one of the small ones is what I'm thinking.
Yep. Yes.
Okay.
Okay. So this is Opportunity took this. The reason why, and again, that's something that I know, but this is what we call the blueberries, and it definitely looks like blueberries. Don't you agree? I mean, we could eat them. So those are actually rocks. They're made of it's concentration of iron, and they just look like they look like blueberries. There's nothing else. And you might think that in the scientific world we speak in very fancy vocabulary and all that. Not always, let me tell you. So we actually call them blueberries. And we, when we write our research and all of that, we do say, hey, so those blueberries and everything. So we're not always extra fancy. So this was taken by Opportunity. So usually Opportunity is the one that encountered the blueberries. That's why I know it's difficult questions, but hey, you got to try. Smaller rover was an amazing guess. So if you've noticed the sequence, you probably can guess this one. It's not the helicopter.
I see your hand up, Summerly.
I'm guessing the Vobo took it. Took the picture.
The small one?
Huh?
Are you talking about the small one?
Yeah.
Yes. So this is another of the small one. This is Spirit. So it's not Sojourner, which is the smallest one, but it's still one of the small rovers. This is Spirit, and this is a the sun rising on Mars, which I think is a really amazing picture. I mean, we have sunrise and sunset on Earth, and we actually do have them on Mars too. So let's talk about Ingenuity. I know a lot of you actually are fascinated by the helicopter. So I just want to ask a quick question. Do you think you fly on Mars? Anyone?
Kia, do you have your hand up?
And it's gonna say that you cannot fly on Mars.
Okay, that's actually a really good answer. So it's very difficult to fly on Mars. So on Earth, do you know what makes flying on Earth easy? Any guess?
Clarissa, I see your hand up.
Gravity.
That makes flying more difficult because gravity is what will attract you to the ground. So to be able to fly, you have to overcome gravity. But what can help you do that? What is on Earth that is characteristic that can help you do that? I kind of say something very briefly about it when I was talking about, being protected from the radiation and all that. Anyone else?
Laura, your hand's up, and Sarah in the chat said our atmosphere.
Yeah, Laura, is that what you wanted to say?
Yes, and also my name's Charlotte. We can't change your name.
Okay, sorry about that. So that's absolutely right. That's the atmosphere. So we have to overcome gravity. So it's true that on Mars, it should actually be helpful because the gravity is a lot less than on Earth. It's about 40% than what we have on Earth. So we have that on our side when we're on Mars. But the atmosphere. So on Earth, the atmosphere is thick enough that, first of all, it's a great protection from the radiation. And it provides enough lift that we can actually fly. So it's great. Now, what do we do on Mars? The atmosphere is really, really thin. So it's a lot more difficult because to be able to lift, so I know the gravity is not as much, but you still don't have a whole lot of atmosphere to do this. And you could actually argue, for example, Venus. I don't know if you're familiar with Venus, but Venus has the thickest atmosphere. So you would think it's easy to fly on Venus. Well, you can actually get the opposite effect where you have an atmosphere so thick that you can barely actually get to the surface. And Venus, it's so hot anyway that you would probably actually burn because it's 400 degrees Fahrenheit on there. So you just don't want to go to Venus. Let me tell you that. All right, so let's see how they did it on Mars because they actually did it. So it's not an airplane, it's a helicopter, but it's still pretty impressive. So I don't know if you can see the helicopter is right here. This is Ingenuity. So you can see the blades rotating here and it's going to take off. And there it is, taking off. So the first time we actually flew on Mars. So when you look at this, what do you notice? You know how helicopters work on Earth. You can probably see them all the time above Morgantown, going to the hospital and from the hospital. What can you tell me? And maybe my next slide will actually be better because I have a picture. I also have the answer. Do you notice the difference between a helicopter that we have here on Earth and what we have on Mars?
There's no place for a person to sit in.
Not yet, but maybe, it's baby steps. We got to start somewhere, right? So we're going to start small. There's actually not even an instrument or anything. There are cameras on there, but that's about it. It's just a test flight. What else do you notice here?
It's very small.
It's very small and the blades are huge compared to the body, right? When you look at a helicopter on Earth, you have, as you said, you have a body and you can fit more than one person in it. You can fit 5, and then you have the blades, but they're not disproportionate compared to the body. And here, it's kind of the impression that we have that the blades are really huge, and that's to counteract the problem of not having enough atmosphere to provide lift. So it has to be way larger than the body, and it has to rotate way faster to be able to actually fly. So that's the first flight on Earth, on Mars. And it's, as I said, baby steps. This is our first, and down the road in years from now, we might be able to actually get the astronauts a helicopter so they can fly and go further. Because the idea with a helicopter is, first of all, it doesn't have to worry about obstacles on the ground. It's not even on the ground. So that would remove a huge problem that we have when we drive the rover, is figuring out where not to go because we don't want to fall into a crater. The helicopter will not have that problem. It can go further and faster and without worrying about the obstacles. So that's amazing. So if we can get, first of all, a helicopter to help the rover navigate, that would be great. The helicopter could be like, hey, this is fine. You can drive here. On Earth, we won't have to do this. We won't have to look at the images, analyze the images, saying, okay, we can drive, send the rover the command, and that takes a while. If you have a helicopter to do this, can you imagine how much time we would save? So just to give you an idea, Curiosity drove 10 kilometers in 3 years. So that's, how is that in miles? 6 miles, kind of want to say. It's not much. Yeah, it's 6 miles in 3 years. That's not very far in a very long time. So the helicopter could actually help us go farther and faster. And when I worked, so now with my lab at WVU, we worked on the next mission after Perseverance and after Ingenuity. Perseverance will actually leave bits of Mars on the ground so that the next mission, which is the sample return, will be able to pick them up and bring them back. So now we have a whole lot more challenges. How do we actually pick up the samples? How do we come back? We're not flying, so we have to care about the obstacles. And how do we take off from Mars? So we have what we call a Mars ascent vehicle. Fortunately, the gravity is less, so it's easier to take off from Mars than it is from Earth. But there are a lot of challenges, and I personally worked on trying to figure out the best path from the landing to the samples, knowing that there's going to be obstacles that we need to avoid. I think that's my last slide. So do you guys have any questions? There are probably a lot, because I see like 54 things on the chat box, so I'll try to answer as many as possible.
Some of the ones from earlier were, how does it charge?
So the Spirit, Opportunity, and Sojourner will charge with solar energy. Perseverance and Curiosity are nuclear powered.
Another question is, will NASA visit other planets?
Yeah, we've been to Venus. Absolutely. We've been to Venus. We flew by a lot of planets. We actually went to Saturn, Jupiter. We're trying to fly a mission to Titan and Europa. So absolutely.
Anna asks, do you think we can plant plants on Mars?
It will take some work. Again, we need to have that habitat that has conditions like on Earth, but they've been able to grow plants in space. If they can do it in space, we can do it on Mars.
Someone asked, what is in the background of this last photo with the helicopter?
The background? This is actually a artist view, so it's not real. It's not a realistic, it's not actually a picture, if that makes sense. This is just a random, like Mars-like landscape.
Anna wants to know, how hot can Mars get?
Well, there's actually a really huge difference between the surface and when you're a little bit elevated. It's actually colder than Earth overall, so it doesn't really get hot. It can get cold.
Julia is asking, why is Mars red?
Actually, there's a a wonderful Mars in a Minute video about it. So the reason why it's red, and if you look up in the sky, well, not today because it's cloudy, but we saw it very well in December, October, in that time frame. There's iron. There's a lot of iron on Mars, and that gives it this red tint. And you can see it in the sky. If you see that star that doesn't twinkle and has that like red orange, it's actually more orange than red. That orange tint, it's Mars, and it's due to the iron content. A lot of iron.
Natalia, you have your hand up. Do you want to ask another question?
She said no. Does anybody else? Yeah, you can ask a question. She said out of the Mars topic. Anna, you might have to describe what you want to ask, but someone asked how are rovers red?
Rovers are not red. Mars is red, or actually more orange, but rovers, their actual Spirit and Opportunity are blue. Like the solar panels are blue.
Wally, do you want to ask a question?
Does the helicopter have solar panels?
It does not. It's only Spirit and Opportunity. Well, and Sojourner.
I don't want to battery.
Anna just asked how long would it take to get to Pluto? That might be a hard question.
It takes about 10 years. So Mars is not that far if you think about it.
Julia asks, how are rovers made?
With a lot of work, a lot of time. So the most important thing, so it's a lot of engineering, you know, building each component, and usually one team of people is in charge of a piece of the rover, and then it's assembled in a sterile environment because we need to avoid contaminating the rover with anything on Earth. So you might see images where you see people all in white covered up because it has to be in a sterile environment.
Yes, Wally, I see your hand up again.
How did the tweeters on Mars form?
The what? Sorry, I didn't hear you.
The tweeters?
Do you mean the craters?
Oh, the craters. So just like they form on Earth, it's actually, if you have a meteorite or a rock or anything that falls and impacts, it will make a really small rock can make a huge crater. And it's what you have on the moon. The moon, you have a lot of craters, and you can see them actually with the naked eye. And it's because it was bombarded and it created this huge holes.
It's hard to concentrate because my brothers keep on distracting me.
Okay, everybody, I guess last call for questions. If you have any, you can raise your hand or type in the chat. Oh, somebody says, did you know there is no wind on the moon?
Well, there's no atmosphere, so there's hardly any wind.
Kia raised her hand.
Does it rain on Mars?
It snows.
Okay, guys, I wanted to thank you all for coming. Since we're not getting any more questions, just some comments in the chat. Dr. Hedrick, we really appreciate you speaking with us. And everybody, I hope you really enjoyed it. Sounds like you were so engaged in this lecture on Mars and all of the different rovers that our lecturer talked about. So thank you so much for coming. I'll see you later at our next session.
All right. Thank you so much, everyone, and have a good evening.
Goodbye. Thank you.
And dream about Mars.
Bye. Bye.
Thank you.